So today's notes have to do with adjacent angles, and it's in your textbook on page 11, as you can see here, chapter 6, section 1. So if you want to make that note, you can. So you have to have these notes with you in order to fill in for the video. When two angles share a common vertex, so for instance, this pair of angles share a common vertex O, or it's off a little bit, and a side, but have no common interior points. So points in between angles COB, I'll do here in blue, and points in between BOA, I'll do here in green. These interior points don't overlap. So COB and BOA are adjacent angles. They share the common side or the common ray of OB. DOE and EOF are adjacent angles. They share the common side of OE. And again, if you put dots in here, you would see that none of the dots overlap because these are adjacent angles. XOY, or you could call it YOX, here's the common vertex point O, are adjacent angles, and they share the common side of OY. So here's a whole bunch of, this is a big obtuse angle here, and here's YOZ. They don't share any common points. That's what that means. You can think of adjacent angles like when you go to the auditorium here at Martha Brown and you sit in a seat and your seat shares a common armrest with the seat next to you. You have something in common. So adjacent means next to and sharing something in common. Your armrest is like that common ray of, for instance, OY in this last example. So that's what adjacent means. They have to have something in common, sitting right next to each other, and something in common. So that's the definition of adjacent angles. So the next slide. In the diagram, QP is perpendicular to QR. Find the measure of SQR. Angle PQR and angle SQR share a common side of QR. Explain why they are not adjacent angles. Oh, okay, we'll talk about this little think math thing in a second. But let's do the what it says. Find the measure of SQR. So we're trying to find this angle here. They are perpendicular, which means they meet at 90 degrees. So this is a pair of adjacent complementary angles. So complementary makes perpendicular 90 degrees. So 90 minus that 41 would give us this angle of 49 degrees. You can see that they already solved that for you. Why is PQR not adjacent to SQR? Because SQR is nested inside of it. PQR is the larger outer angle. It's all of the two angles put together here. And SQR is inside of PQR, that blue one. So those are not adjacent. But if they had said PQS, like here, PQS and SQR, those are adjacent because PQS would be this red part here, and the red one and the green one would be adjacent, but having the larger blue one and then setting an angle and slicing an angle inside of it, that's not adjacent angles. So that's what they're trying to point out here in this little think math idea. In the diagram, the measure of angle ABC is 90 degrees. Find the value of X. So if ABC, the entire angle, is 90, and DBC is 23, so they are complements. So we're going to get an angle measure of 67 degrees. 67 and 23 makes that angle of the complementary adjacent angles. So X would equal 67 degrees. The properties of adjacent angles that are on a straight line. So now we're going to have adjacent and supplementary angles. So XOZ is the straight angle which measures 180 degrees. XOY and YOZ have to add together to make 180. So in the diagram below, so each part of this is a pair of adjacent angles. What they share in common is O, and they have this ray in common. So if you know part of it, you'll know the other part because they are adjacent and supplementary. In the diagram below, POR, ROS, and SOQ are also angles on a straight line. PQ, the straight line PQ. So here's the line PQ. They're calling it a line. Notice it doesn't have 3 letters in it. It's not calling it an angle. It's calling it a line. Notice that POQ is also a straight angle. Now they put the third vertex point in there, so now you can call it an angle because you have to have 3. You have to have a vertex in the center to call it an angle. So the measure of POR, ROS, and SOQ equals 180 degrees. This is 3 angles. These are not supplements because there's 3 of them. Only a pair of angles is supplement. So POR, as it says here in this caution, and ROS and SOR are not supplementary because they are not a pair of angles. But if you can have 3 things or 4 things or 5 things that add up to 180 degrees because they make up a straight angle. They're not supplementary. The sum of the measures of the angles on one side of a straight line is always 180 degrees. So angle 1, angle 2, and angle 3 for POR, ROS, and SOQ are all going to add to 180 there. Given that PR is a straight line, find the value of X. So you can see they've done this here for you. They've taken 180, subtracted the 125. So this would make X equal to 55 degrees. Very easy to do because they make that straight line. This is a pair of supplements because there's 2 of them. So they are also supplementary. They're adjacent because they share ray QS, and they are supplementary. On page 14 in the text, you would see this diagram. AOC, COD, and DOB are angles on a straight line. So these are not supplements, but they do add to 180 because they are on a straight line. The straight line AB. So the measures of these 3 angles has to add to 180. This whole half of arc here has to add to 180 degrees. So AOC, COD, and DOB has to add to 180. Well, here we have like terms, and you're going to see geometry, algebra in your geometry. So adding your like terms together here, 126 plus x plus 2x, you get 3x's. X plus 2x makes 3x. Subtracting 126 from both sides, you're going to get 3x equals 54. Dividing by 3, you get x equals 18. So COD is 18 degrees, right? That's x. And twice of that would be 36 degrees. So to make sure that you solved this correctly, you should add your 3 angles together, 126, 18, and 36. Here's your little check to make sure that these do add to 180. And yes, 6 and 6 is 12 plus 8 makes 20. 2, 4, 5, and 3 makes 8. So you get 180 degrees. So this math is all correct. And of course, hopefully the book is correct, but sometimes they make mistakes. So this does all check. Given that PQ is a straight line, find the value of Y. Given that PQ is a straight line, find the value of Y. Well, this is a pair of supplementary adjacent angles. So 180 minus 37 here, which is 143 degrees, equals that Y. In example 7, however, you have some like terms here. These are not supplements, but they do add to 180. because they told you that line PQ is a straight line. So straight line, all of this has to add to 180 degrees, that half arc there. So to solve this, you're going to add 2y plus 70 plus 3y has to equal 180. So 5y's, like terms, plus 70 equals 180. So you have two-step equation here. Subtract 70. You get 5y equals 110. What would you guys do next? Divide by what?
5.
Divide by 5, yeah? Divide by 5. Y would equal 22 is correct, yes. Y equals 22. So my 2y is how much?
44 degrees.
Yeah, oh, very good, Josh. 2y equals 44 degrees. Got to put that degree symbol on there. And 3y, 3 times 22, everybody?
66.
66 degrees. Thank you, first period. 66 degrees. So 2y is 44 degrees and 3y is 66. How do we check to make sure we got the right answers?
You add them all up.
So what do we add?
44, 66, and 70.
44, 66, and 70. Well, that's 110.
Plus 70 is 180.
Thank you, Dylan. So we're going to get 180. 44 and 66 is 110, plus that 70 makes 180. There's our little check. So our math is correct here, our two-step equation with like terms. So you are going to see some algebra in this unit. Using ratios to find unknown angle measures. This is a little tougher. In the diagram, there's two ways you can do it. You can do it through the bar model, as you can see here towards the bottom, or you can do it using algebra. In the diagram, the measure of PQR is 90 degrees. The ratio of A to B is 1 to 2. So B should be twice as big as A. It kind of looks like it is. It looks like it's kind of drawn to scale. Find the values of A and B. So in the bar model way, as you can see that they've done here, using a bar model, A plus B has to equal 90. B is twice of A, so they use two little bars to measure for B, one for A. So 3 units, as you can see, 3 little rectangles here, is 90. To find 1 unit, divide by 3, you get A is 30, and B would be 60. So 30 and 60, yes, 60 is twice of 30, makes 90. So you could do this. We would just write 3u equals 90, and then divide by 3 on both sides. So 1 unit is worth 30, 2 units is worth 60 degrees. Yeah, somebody can answer that, but that would be great. On page 16, the other way you could do it is to, give it a letter. So A would be, it's a 1 to 2 ratio, and I usually use X, not A, so I'll say 1X plus 2X. So 1X and 2X, 1 and 2, they're in the ratio of 1 to 2. So just put a variable on those. Whatever the ratio is, put a variable with it. So 1x and 2x gives you 3x. Dividing by 3, you get one of them is 30 and one of them is 60. And another example, they're in the ratio of 1 to 4. Altogether, you have 5 of them. So here, when you divide 90 by 5, you're going to get 18. And 4 times 18 would give you 72. Really quickly to finish this. And 1x, they're using x and y. I would say 1x plus 4x gives you 5x, and 5x has to equal 90. So again, dividing by 5, you get 18n. And 4x would be 72. So thank you, first period, for helping make the video. That's it for today.
First period.
Bye, John.